for a binomial distribution, okay, with n is the number of trials, p is the probability of success, and q is the probability of a failure. Then to calculate the mean, mu, we literally take the number of trials multiplied by the probability of success. And that's it, okay? That is it. To get the variance, sigma squared, I take the number of trials times the probability of success times the probability of failure. To get the standard deviation, I take the square root of the variance, so that's the square root of NPQ. All right, so the square root of NPQ. Now, to give you an example to show you exactly how easy this is, take our doctor example. We had six surgeries. We had a probability of success equal to 70%, which implied a probability of a failure equal to 30%. Typically, you're only going to be given those, and you can find Q by just doing the complement rule. 30% chance of failure means a 70% chance of success. Okay? So do your 1 minus to get that complement there. Now, I plug in. All I have to do to get the mean, easy points right here, people. 6 times 0.7. That's it. That's 4.2. Variance, 6 times 0.7 times 0.3. So that's going to be 1.26. Standard deviation, I take the square root of 1.26. Or the square root of 6 times 0.7 times 0.3. And what do I get? 1.122. Okay? That's it. That's all there is to it. Right? So how could I interpret this data? On average, there are 4.2 successes or successful surgeries okay, for every 6 surgeries, with a standard deviation of 1.12 patients, values that are more than 2 standard deviations from the mean are considered unusual. Okay, so what am I saying here? So values that are more than 2 standard deviations away from the mean, these are unusual. So the mean minus 2 standard deviations and the mean plus 2 standard deviations. So that is 4.2 minus 2 times 1.12, and then 4.2 plus 2 times 1.12. And so this is 1.96 and 6.44. So what does that mean? Less than 2 successful surgeries and more than 6 successful surgeries would be unusual given a 70% success rate. Okay? Now, if you think about it, with 6 people, you can't have more than 6 successful surgeries, right? So that upper bound is kind of meaningless, right? But if you had 6 surgeries in the day and you had no successes, like you had 0 successes through the day, or you had 1 success, or you know, if you had 0 or 1 successes, the medical board might be coming in and looking at you like, dude, what happened today? Like, were you drunk or something? Like, how come you killed 6 people or 5 people out of 6? Like, that's really high for the number of people that you had surgery on, and there's a 70% chance of success. So they look at these numbers through these probabilities to make judgments on, do we need to take this doctor's license away, right? So there might be a question of, are these events unusual, right? And so remember, 5% or smaller, that's unusual. And if you think about our probability distribution that we found in the last video, when we look at this, which events are unusual? Well, it looks like the probabilities that are unusual are when we have 0 successes and 1 success. Okay? And they're unusual because these percentages are less than 5%. Once you get into 2 successes, that's 6%, and it just goes up from 6% for those. Okay? So that's the idea of what's going on there with your mean, your variance, and your standard deviation. Okay? If you think about it just for a second, you intuitively knew how to calculate the mean before you ever walked into the classroom. If I told you, hey, there's 10 people in the room and there's a 70% chance that you like ice cream, how many people in the room like ice cream? I guarantee you would tell me that 7 people like ice cream. And how do you know that? How do you expect that? That's the expected value, right? How do you expect that to be true? You multiply the number of people times the percent to get the 7. Okay?